Good morning, ladies and gentlemen. You are welcome to Electrical and Fire Hazard and Safety Management. This is a second semester course, and today we'll start with the general introduction to the course. We'll start with the general introduction to the course. So please, I'm starting the course and I'm recording it for those who cannot join us. We will meet when it is recorded. So I said electrical and fire hazard safety management is the course we will be. Under this course, these are the following things we are expected to know and understand. Raise the awareness to potential electrical hazard, how to recognize electrical hazard, provide ways to eliminate, remove, and prevent electrical hazard in workplace, emphasizing the extreme importance of observing all electrical safety requirements and practices, what to do in an event of an electrical hazard. A lot of people get electrocuted, a lot of people come in contact with electrical hazard during their work or among their colleagues. So how do we help people who get shock, who get blast, or who are in contact with electrical hazard? So what is the main purpose of this course? So as a professional health safety professional, the main purpose of this course is to give information regarding electrical safety, how you share scenarios, and help students to understand and have the ability to identify and describe electrical hazard. Make available precautions that should be taken to avoid injury at workplace. So what is the learning outcome? Basically, the learning outcome for this course is basically you understand what electrical setting is, what is current, what is voltage, what is an ampere. The basic species surrounding electricity are the general rudiments each student must know in this course. Explain how electrical current adversely affects the human body. Describe the steps and touch of potential hazard. Explain safe work practice requirements for non-electrical workers. Explain the characteristics and hazard associated with power acts and precaution that should be taken to avoid injury in case there is a blast. What will our outcome be? At the end of this course, the possible hazard caused by electricity should be understood and generally familiar with the students. Safety measure and practice to avoid those hazards are things we must be familiar with. Duties of building premises management in ensuring safety of electrical installation. Applicable statutory requirements on safety standards regarding to electrical works, equipment, and installation. Let's watch this video and see what is happening. You can see from the video what really happened there. They were carrying a scaffolding, and the scaffolding is a metal type. However, they are not cautious of their immediate environment. By the left side towards the fence, there is a wire, a power cable wire running on the fence. That is where the metal scaffolding touch the electrical current. You can see all the workers within 2 minutes dead. The other one is even burning. That is the power of electricity. It can burn and turn a human body into ash. So this is a typical example of an electrical hazard, killing workers and even burning them alive with less than 5 minutes. It's a very terrible accident. No worker, no person should face this kind of scenario. It is highly unexpected. So most industrialists, most HSE personnel don't want to witness this kind of incident. So for us, for this kind of incident not to repeat itself, what are the precautionary measures we must put in place? First, are the workers properly kitted with proper PPE? That is one consideration we must look at. Are they having proper PPE? 2, do they have survey their environment? So when you want to work in an environment, you must be able to what? See, one of the workers wake up and is trying to escape, and what happened? He got shocked again. He got shocked again. So we must be able to survey our environment. We must be able to look at our vicinity. What are the inherent hazards within our vicinity before we start to work? They are carrying a metal scaffolding, but they were not careful about the electrical wire on the fence. These are things that is very, very crucial. These are things that is very, very crucial. Let's look at so we have been able to So from there, we are able to understand that electrical hazard is a very, very dangerous thing. Electrical hazard is a very dangerous thing. So basically, electrical hazard can be categorized into three. The first and the most common recognized electrical hazard is shock. Most of us are familiar with that. Shock. When somebody touches a current, it gets shock. The second one is electrical burns. The second one is electrical burns. When you get in contact with an electrical material, it burns off the skin or it burns off the body. A classical example is what we just watched in the last video. The third effect is blasts. The third effect is blasts. Example is the second video that shows how electrical blasts can occur, and which can come in form of a pressure impact. It can also come in form of a flying particles or through a conductor that causes an effect. So electrical shocks occur when the body becomes part of an electrical circuit. How do electrical shock occur? Electrical shocks occur when a person's body comes in contact or becomes a conductor in electrical circuit. So a person may come in contact with both conductor in a circuit, it gets shock. A person can also provide a pathway between ungrounded conductor and the ground. That means if you are touching a current and your body serves as a conductor to the ground, you can also get shocked. A person may provide a path between the ground and the conducting material that is also can cause a shock. So the terms high voltage and low voltage are relative terms that are used to describe how a person gets in contact with electricity. So the term high voltage and low voltage are terminology that are used. So sometimes a low voltage is as much higher than 600 volts. At home, we will not think of 600 volts of being a low voltage, even when applied to 120 volts. So sometimes a low voltage is something that is lower, while a high voltage is something that is higher. Actually, a low voltage does not necessarily mean a low hazard, no, because potential difference is only one factor making up the dangerous effect of electricity. For the purpose of this lesson, you can think of low voltage as being a potential difference of between 24 volts to 600 volts. So, how do electrical shock occur? And how does the electrical shock injury occur? The extent of injury accompanying electrical shock depends on three factors. So, three factors contribute to electrical shock. One, the amount of current conducted through the body. So if the current is higher, you can get shock. So you cannot take a current of 2 amp to a current of 15 amp or a current of 300 amp. So which means how you get shock depends on the kind of current you receive. If you are trying to do something in your house and you mistakenly touch the wire, you felt jittery. That's a little shock. But if you try and go and touch a transformer, you become shocked. The second one is the path at which the current passes through your body. The current pathway can also determine how you get shocked. The current pathway can also determine how you get shocked. So which means if you have a dry skin, you can see some people are known for holding wire. Some people can hold wire and nothing will happen to them. probably they have been able to develop muscle that is very, very thick. So if your leg, the dry part of your body, touches a wire, there's probability that you don't get shock. But if your body is wet, there's probability that you get shock easily. The last part is the length of time a person is subjected to the current. If you touch a current for a few seconds and you quickly drop it, there's probability that you won't get shock or you won't die from it. But if you hold a current for a longer period of time, there's probability that it will cause injury and there may be death. A death may occur because you are holding the current for a longer time. So the extent of injury accompanying an electrical shock depends on 3 factors. 1, the current conducted through the body, that means the amount of current that passes through your body. 2, the part at which the current comes through your body. How the current passes through your body, it's also a factor. The 3rd one is the length. If you get shocked within a second or 2, and you quickly drop the wire, there's probability that it will cause injury. But if you hold it for more than 5 minutes, 3 minutes, 10 minutes, there's probability that apart from shocking you, it can also lead to death. So the amount of current depends on the potential difference and the resistance. The current that comes into your body depends on the potential difference of the current and the resistance. Average, the effect of low current on human body range from temporary mild to tingling, just a little sensation, or to death. So if somebody uses an electrical wire on your body and quickly remove it, you feel a sensation in your body, like a shock. But if you put it on you for a longer time, it will lead to death. So the electrical shock can injure you or it can kill you. It can cause severe stop to the heart. It can cause the breathing muscles. Some electrical current can even tear the muscle. Some it can cause burns. Some it can even leave the person paralyzed. So that is our general introduction about electrical hazard and fire. So basically what we have been able to discuss today is what are the potential electrical hazards that we face. How do we recognize electrical hazard? So when we recognize it, how do we eliminate it? How do we remove it? How do we prevent it? So, how do you, as an HSE officer, stop an electrical accident in your industry? So let's go back to our video. Let's go back to our video and let's look at the second video. We will look at the second video and take it as a case study for how electrical shock can kill a person.
But there is another water I must tell you about, which you need more desperately than even the water in your hand.
The electrical workers who are working. Let's look at this set of electrical workers with the first set of people that we watched in the first video. The first video shows the workers who are not properly fitted. They don't have proper PPE. These ones have an helmet, they have an overall. You can see the blast. You can see the blast. You can see the blast. Let's have a replay of it and see in a slow motion. You can see the blast. So what differentiates this incident from the other accident? What differentiates this incident from the other accident is that the worker are alive. They are alive because they have their PPE on. They are properly kitted. The other one, no PPE, they are not properly kitted. And what happens? It leads to their death. It leads to their death. So as an HSE supervisor, as a manager in a company, as a supervisor in a company, when your workers want to work on electrical components, there is need for you to do due diligence. There is need for you to do due diligence. Check each and every one of them, whether they are properly kitted. If they are properly kitted, did they tag in? Is there a tag out? Make sure that everything is checked before you commence the activity. Make sure that it is checked before you what? You commence the activity. Make sure you check.
Please, this person living very close to church should leave that place or switch off his own phone.
So
who is within the church or beside the church is obstructing this program?
So that is our general introduction about electrical hazard. So we have been able to look at electrical hazard is, the category of electrical hazard we have, and how electrical shock happens to us. Electrical shock can come in 3 ways. Electrical shock can come in 3 ways, and it can come in 3 parts. It can come in 3 ways, and it can come in different parts. So an injury from electrical shock can also be accompanied when the current passes through the body. When the current passes through the body, or your body serves as a conductor. The time at which you get exposed to electrical current also determines how things happen to you. Thank you, ladies and gentlemen. That is the general introduction about our course today. So if you have any question, if you have any observation, that is just a general introduction about the course. We'll start with the course proper. So you know what the course is all about. The course is about electrical hazard. It's about electrical shock. So we'll be seeing videos that are horrible. For those of us who are allergic to horrible videos, this permits it's an advance course. Also, we'll be doing some little physics. We'll be doing some little what is current, what is ampere. We'll be learning some terms that has to do with physics. So those of us who don't have physics background, please permit us. It's just for a little time. So thank you, ladies and gentlemen. That is the general introduction for today's course. So if you have any comments, any question, I welcome you. I can only see 2 students. 2 students are available online.
Yes, sir.
Okay. So any question, any comments?
Hello, sir.
Hello?
Is somebody receiving this lecture very close to church? Is obstructing this program?
That should be your second. That should be your second. That should be Anna.
Anna, kúrò ṣọ́ọ̀ṣì now. Kí ló ń ṣe ní ṣọ́ọ̀ṣì ní class?
You can't
be. You are obstructing seriously.
There's just I can get network.
Anike kókó nùgbó ṣọ́ọ̀ṣì yìí. Oh, why the Rose Express?
Baba kọ́ lọ Rose Express. Kọ́ lọ Rose Express.
The pastor yẹn kó máa postpone program ẹ̀. Ẹ wà méjì nìkan la attend the lecture yìí.
Méjì nìkan la attend the lecture.
Ọ̀gá yẹn yà tètè send díẹ̀ o.
Ẹ̀yin méjì nìkan la attend.
Ètò jẹ́ pé ṣé ID náà la máa fi wọ the next lecture àbí ID kejì.
No, next lecture ní ID tiẹ̀ lọ́tọ̀.
No, it's another one.
It's another one.
Only ID tiẹ̀ lọ́tọ̀. The second one is there.
Torí the first one yẹn ni mo login tó jẹ́ late wọlé.
Okay.
Mr. Lasisi.
Yes, ma'am.
Kí ni fídíò tẹ send sí wa nípa iná tó ṣẹlẹ̀ yẹn? As you know wo nìyẹn.
Electrical, Sherry, you know,
It's electrical fire now. It's electrical shock.
That is what we call an hazard.
That Argentina they were pushing, unfortunately, has a contact with a current electric, which ignited that fire.
That is why we are explaining that sometimes electrical current can burn a human being into pieces. You know, they run, there's an electrical cable on top of the fence. So when they were carrying the gantry, the scaffolding, they were unable to visualize their environment. So if you want to do any job as an HSC professional, the first thing you do when you want to carry out a job is assess your environment. Assess your environment. That's very, very important. They are not able to assess their environment very well. Number two, they did not wear proper PPE. Imagine if they wear gloves. If they wear rubber gloves, they will not be able to get shocked. But because they did not wear rubber gloves and they were using their hand directly, what happened? They get shocked. So it's a lesson. It's a lesson for us others that any work we want to do, the first thing for you to do is what? Assess your environment. What are the potential hazards that I can face in carrying out this work? So before you even do it, and that is why toolbox, that's why toolbox is very, very important. Before your workers start work in the morning, you call all of them. Today, we are doing a fence. We are running a fence from point A to point B. Okay, we are doing this fence, and the fence is 100 blocks. But you have 50 workers. The fence you are going to do is 100 blocks, and you have 50 workers. So why do you want to use 50 workers to do 100 blocks? There are too many. So there's probability that they will be rushing, and they can cause injury. So you divide the job to them. Okay, some of you, because you have 100 workers, all of you have resumed today, and I have only 100 work blocks to set. So if each one of them carry it, they will finish it in 1 minute. But it will cause commotion at the site. So that's okay. Some of you will be helping me to carry the block. Some of you will carry water. Some of you will mix the cement. All of them say, I know, I can mold block. We know all of you can mold block. But if all of us rush, if all of us rush at the same time, there will be accident and there will be what? Injury. So it is very, very important for supervisors, for HSC manager to design safety protocol for each work. I'll give you an example. There is somebody that wanted to go and connect a DSTV cable. He wanted to go and connect a DSTV cable in a place. And the house where they want to fix the DSTV cable has paving stone. And he just said, okay, let me go upstairs. He went upstairs, but unfortunately, he could not. So he asked one of the co-workers to help him to set the ladder. The co-worker who set the ladder, it's about 50 kg. But the person that is up before the ladder was set is over 70. So when he wanted to descend with the ladder, the ground they put the paving stone, it's a soft ground. So while coming down, just collapse and he sink. There was a sinkhole there. But the person who set the ladder has a little weight. But if he has set the ladder downstairs himself, he will have known that that ground is what? Soft, that he can't carry the weight of the ladder. So it is very, very important for us to assess our environment. When you assess your environment, you now decided to do what you call elimination. You will eliminate hazard. If I carry this thing up, there's probability that it can touch this wire. But they didn't do that. Number two, this thing that we want to carry, my hand is wet, and I want to do an electrical work. If you want to do an electrical work and your hand is wet, what should you do? You stay away. You go and do what? You go and make sure that your hand is what? Dry. Sometimes people do electrical work and the house they are working is not heated. There's no heating in the house, which means there can be current reports. So these are the hazards that occur. So basically, those are the things we are going to learn throughout this course. Electrical hazard, we'll be giving an example of how people get shocked and how we can assist them, the kind of current that people get exposed to and get shocked. So this is a general introduction. So our 45 minutes is not up. So what I would do now, I'm recording it, I'll still upload, but you need to tell others that the next one will start by 10 o'clock. So you have like 40 minutes to inform them. Maybe they are busy. That's why they are unable to attend. Even your
Anna will not do the next lecture.
Even your
unless he leave that church.
Your governor is not even available. Anna, Shotibo, why don't you go in the church so that you won't use church to disturb us? Okay, let's go and prepare while we join the next class by 10 o'clock. Are we all right?